So in this lesson, we're going to be continuing our conversation about aspects of an electric circuit and current electricity. In the last video, we looked at defining and trying to get an understanding of what electric current was. And today we're going to be looking at a different term, and the term is called potential difference. And so, but you may know it more with its more familiar term, which is voltage. So when we're talking about current, we were simply looking at how many, or the number of charges that were flowing through a circuit in a given amount of time. In other words, the rate of flow. But there's another aspect of a circuit that's really important to consider, and that is the energy that each individual electron has as it's passing through the circuit, and how much it's willing to give up in order to power that load. And so when we talk about the energy of each individual electron within a circuit, that is what we call electric potential. I'm going to switch to a gizmo to give you a good understanding of what this looks like. And so what I've built here is just a simple circuit with a single light bulb as my load. And so if I turn this switch on, I'm going to see what my current looks like. Right? And so I can see through these little blue dots what my current looks like. It's moving through. And so that describes just the current on its own. I'm going to turn off the current so we can focus on something called the voltage. So I'm going to switch to my battery, and what I want you to pay attention to is this light bulb right here and its relative brightness. So right now my battery is operating at a voltage of 1 volt. And so what I'm going to do is I'm going to switch this voltage. I'm just going to increase it slowly, and let's pay attention to what happens to my light bulb. So what you're seeing, you hopefully can see here, is that as my voltage increases, so does the brightness of that lamp. So if we talk about what voltage is, what electric potential is, it's describing what's going on with the electrons in terms of their energy level. So an electron that possesses a whole lot of energy coming out of my battery is going to be able to give a lot more of that energy up as it passes through the load, as opposed to a weaker or a lower energy electron traveling through that load. It's not going to be able to give up as much energy to power that load. So when that negative charge leaves my battery and passes through the load, it's going to lose some energy, and so it's going to be drawn back to the positive terminal in order to get some of that energy back. In other words, to re-energize. So you can imagine that an electron leaving the negative terminal has a lot of potential to move through the circuit, and what it has the potential. Why does it have that potential to move? Well, it's attracted to the positively charged positive terminal. So we talk about there being a potential difference in the circuit created by the fact that I have this negative terminal expelling electrons, and over here this positive terminal which wants to draw it. So there's a difference in the electric charge in different parts of this battery, or circuit rather, simply because there's the potential for this electron to move through the circuit towards the positive terminal. And that potential is caused by the difference in the two charges. So that's why it's referred to as potential difference. I want to show you a quick animation to demonstrate this. Okay, so imagine your circuit as almost like being delivery trucks, right? And so in this case, well, what are they delivering? They're delivering the current, which is electric charges. But those electric charges, the individual ones that are shown by these green little balls on the trucks, those electric charges have a certain amount of energy, right? And so you can imagine that as those truckloads of charges are traveling to where they need to get delivered, where they need to do their work in lighting the light bulb, that they use up that energy. And so by the end of it, the truckload of electrons is used up, if not entirely, then partially, and then they have to go back to the battery to be recharged. That's really what electric potential is. And so what is drawing these trucks back to the battery? Well, it's the fact that they're empty and they need to get re-energized. Okay, and so let's look at some symbols that we use for electric potential difference. So electric potential difference, because it's often called voltage, well, that actually comes from the fact that the unit that we use to measure voltage or potential difference in is called the volt, and it has a symbol V. Now, luckily, in a formula, we're also going to see voltage or potential difference with the symbol V, and so that makes it easier to remember. So what I have here for you are a few videos that I'm going to post as well on Google Classroom in order to help you see the difference between current and potential difference, explained in some different ways that you may find useful. So make sure to check those out if you're struggling or you have more questions. And so just like current is measured in amperes, and so we use an ammeter to measure the amount of current moving through a circuit. Potential difference is measured using a voltmeter because we're measuring the amount of volts. And so in analog version it will look like this, in digital version it will look like this, and just as the ammeters can be useful for homeowners or electricians or engineers or whomever wanting to measure current, the voltmeter can kind of have the same function. So you'll remember that a voltmeter is really just measuring the difference in energy from at one point in a circuit to the other. And so unlike an ammeter, we're not going to put the voltmeter in series. We're going to put it in parallel with the particular object within the circuit to measure the difference in the electrical energies sort of before and after as the current passes through. So I'll explain a little bit more about that in a second. So showing you a diagram that includes both a voltmeter to measure the volts and an ammeter to measure current. So here would be my cell. I've drawn in a resistor which functions as my load. And so I might want to measure the current passing through this circuit, but I might also want to measure the energy or the potential difference as the current moves across and through this resistor, right? So that my ammeter is in series with the resistor, but my voltmeter is in parallel. So let's talk about this in practical terms, because what is a volt? What does a volt kind of look like, and how many volts do some common things sort of exhibit? So a human cell, if we were to look at it, has a voltage of about 0.08. And so that's quite small, but our nervous impulses actually rely on electrical energy. And that's a topic that we discuss in more detail in grade 12 biology. So an electrochemical cell, so for example, like an AA battery, those depending on the type of battery might have 1.1, 2.9. We even have a 6 volt lantern battery that we use in class. Those are just some common volts, right? A wall outlet at your house is going to be releasing, depending on what type of outlet it is. Your common one will be 120 volts, but some larger items like, for instance, your stove will have 240 volts just because more energy is required to power that item. And then a power station generator is going to have way more volts, and that's where we start to get into a dangerous situation. So we need to be cautious around that. So I will post the textbook section related to potential difference on this Google Classroom post so that you can read through for additional information, or also complete the homework that's associated with this. And of course, remember to save any questions that you have for me for when we get back to class together.